Good morning to everyone. This is Dr. B. Kondareddy from PBR Wits. I am going to teach in this semester kinetics of machinery. Now, the syllabus as per JNTU of this kinetics of machinery will discuss first. So, this subject consists total 5 units. So, unit 1, elements or links, classification, rigid links, flexible link and fluid link. Types of kinematics of pairs: sliding, turning, rolling, screw and spherical pairs, lower and higher pairs, closed and open pairs, constrained motion, completely, partially or successfully constrained and incompletely constrained motions, and mechanisms and machines, classification of mechanisms and machines, kinematic chain, inversion of mechanisms, inversions of quadratic cycle chain, single and double slider crank chain, mobility of mechanisms. So this is first unit. Coming to the second unit, unit 2, straight line motion mechanisms, exact and approximate copied and generated types of straight line mechanisms are having. In these examples, Piesler, Hart, Scott-Rogel and Grasshopper, Watt, Chebyshev and Robert mechanism, pantograph. So these are some of the straight line mechanisms. Next, coming to the second chapter in this second unit, steering mechanism, conditions for correct steering, Davis steering, Ackermann steering gear. So these are the two types of steering gear mechanisms. Next, coming to the hook joint, third chapter in this second unit. Hook joint is also called as universal coupling, single and double hook joint applications, simple problems on this hook joint. So this totally first 2 units are most of the 90% is theory. So only hook joint problems may get. Now coming to the third unit, velocity and acceleration diagram. Velocity and acceleration, motion of a link in machine, determination of velocity and acceleration, graphical method, application of relative velocity method, slider crank mechanism, 4-bar mechanism, acceleration diagram for simple mechanisms had to draw, and determination of Coriolis component of acceleration, and Klein's construction, analysis of slider crank mechanism for displacement, velocity and acceleration of slider using analytical method. Next, coming to the instantaneous center method. So instantaneous center of rotation, centroid and axode definitions, relative motion between two bodies, 3 centers inline theorem, locating instantaneous centers for simple mechanisms, and determination of angular velocity of points and links. So this is the completely third unit. This is most of the cases they are asking problems only. Maybe use graphical method or analytical method. Now coming to the unit 4, so gears is the first chapter. So these gears are used to transmit the power. So now in this higher pairs, 2-3 gears, types, law of gearing, and condition for constant velocity ratio for transmission of motion, forms of tooth, cycloidal and involute profiles, velocity of sliding, phenomena of interference, methods to avoid interference, condition for minimum number of teeth, and expressions for arc of contact and path of contact, introduction to helical, bevel and worm gears. So this is about the total gears. So this is only mainly terminology related to this, and gears problems will be there. So most of the cases in this chapter they will ask the problem or these derivations they may ask. Now coming to the second chapter in this unit 4, gear trains. So this gear trains, introduction, types of gears, simple, compound, reverted and epicyclic gear trains, train value, methods of finding train value or velocity ratio. So generally tabular column method is used for epicyclic gear train. This is one of the important topic. Torque in epicyclic gear train, differential gear of an automobile, simple problems being asking. Coming to the unit 5, CAMs. So definition of cam and follower, uses, types of followers and cams, terminology, types of follower motion, uniform velocity, simple harmonic motion, cycloidal, uniform acceleration and retardation, maximum velocity and maximum acceleration during outward and return strokes. So drawing of cam profiles. So this is one of the important thing, drawing of cam profile or design of the cam shape. The analysis of motion of followers, tangent cam with roller follower, circular cam with flat face follower and roller follower. So these are the syllabus. Now coming to the textbooks for this subject. So theory of machines and mechanisms, S.S. Rathan, Tata McGraw-Hill publishers. So this is the most prescribed book. This is useful book. And second one is another textbook is prescribed book is Theory of Machines by R.S. Kurmi and J.K. Gupta, H.Chan publishers. So these two books are prescribed books. Coming to the reference books. So Theory of Machines by Thomas Bevan and Theory of Machines by R.K. Bansala and Theory of Machines Sadhu Singh, Pearson Education publishers and Mechanism and Machines Theory by J.S. Rao and R.V. Dukkipati, New Age Publications. The Theory of Machines by Sigley, Oxford Publications and Theory of Machines P.L. Balani, Khanna Publishers. So these are the most of the references you can follow for this subject. Now coming to the online learning resources. So these are the available. So these online resources for videos and we can see how the mechanism is working and everything by observing these by pressing these websites. So now coming to the theory of machines introduction first. So before going to the kinetics of machinery, what is theory of machines? So because kinetics of machinery is a part of theory of machine. So one part of theory of machine. That first we will discuss about what is theory of machine. So it is a branch of engineering science which deals with the study of relative motion between the various parts of machine and forces which act on them. Generally, theory of machines is one of the subject in engineering science, so which deals with the relative motion between the various parts of a machine and forces which act on them. So this, what is the necessity of study of this subject first? So this is very essential for designing of various parts of a machine. So as a mechanical engineer, you have to design the various components of machines. For this, you should thorough knowledge is required for of this subject. So now, before going to this, so kinetics of machinery, what is meant by machine first? So machine is a mechanism or combination of mechanisms which imparts the motion to the parts. Generally, it is a combination of mechanisms. Okay, it may be a single mechanism or combination of mechanisms which should get the motion to the other part, also transmits and modifies the available energy into useful work or desired work. Okay, some available energy has to transform into mechanical or useful work or desired work. So that is called as a machine. So any one which is a combination of mechanisms or machine, okay, which transmit the motion as well as which implement or imparts the motion, or same time it will be transforms the available energy or transmits and modifies the available energy into desired work. So that is called as a machine. Now coming to the mechanism. What is meant by mechanism? So you said that we discussed about the machine, nothing but combination of mechanisms. So first, what is meant by mechanism? So mechanism nothing but it is a combination of number of rigid bodies, or number of rigid bodies are assembled in such a way that the motion of one causes constrained and predictable to the other. Okay, so different elements may be joining. So that in that one motion, one of the element motion is causes to the other element motion or element or body. So that is called as mechanism. Examples are single slider crank mechanism, valve mechanism, and watches, spring toys. Generally, we are observing toys. So spring toys also working because relative motion will be there. So there is no forces or which will not be useful work you are not getting from the toys. So that is the one of the mechanism. Okay, if it is getting useful work, then it is called as a machine. If it is not only, if it is not getting useful work, it is only some motion is transmitting, then it is called as a mechanism. Example, olden days, now it is not, it is mechanical watches were there. Okay, olden days only mechanical watches, now it is anyhow electronic watches. So that is not, electronic watches will not comes under the mechanism, but in this olden days mechanical watches were there. So in that only motion is transmits, so there is no desired work. Okay, you will not conversion of energy is not there. So that is one thing. And similarly in IC engines we are studying valve mechanism. Okay, already thermal engineering subject we were studied. Okay, that is valve mechanism. And slider crank mechanism, like any engine, cylinder and piston, connecting rod and crank, totally combination of different links. So these will be transmit the motion. This will not be getting any desired work. Only mechanism we are taking. So if it is different mechanisms you are joining, that may becomes an engine or it may be called as machine. Engine is also called as a machine, but all machines will not be engines. Okay, from the mechanism we can get desired motion but not useful work. So already I told you. So mechanism is a combination of links or combination of elements, okay, which will get the desired motion, which will not get any useful work. So if it is getting useful work, that can be called as a machine. Machine we can get desired work in addition to the desired motion. So in addition to the desired motion, we are going to get desired work, then it is called as a machine. Okay, study of mechanism involves its analysis as well as synthesis. So what is meant by analysis? What is meant by synthesis? Now we'll discuss. Okay, study of mechanism nothing but analysis and synthesis both. Analysis is nothing but, so we are studying the forces and their effect on existing parts. Okay, that we are called as analysis. Synthesis nothing but we are designing new part or different parts you want to modify or you want to get new modification of the machine part, then it is called as a synthesis. Okay, this is about the mechanism introduction. Now theory of machines already discussed. So theory of machine is the kinetics of machinery is part of theory of machine. So what are the different parts of theory of machines? Now we'll discuss subdivisions of theory of machines. So kinematics. Kinematics nothing but it is a branch of theory of machines which deals with the relative motion between the various parts of the machines. Now dynamics, next one is kinematics. Kinematics nothing but only we are studying the relative motion between the various parts of the machines. So we are not considering any forces effect. Then it is called as kinematics. Now dynamics nothing but it is a branch of science, theory of machines, which deals with the forces and their effects while acting upon the machine parts in motion. Whenever the machine parts are in motion, so we are studying about the forces and their effects, that is called as dynamics. So now dynamics once again we are taken as kinetics, okay, and statics. So kinetics nothing but it is the branch of theory of machines which deals with the inertia forces which arise from the combined effect of the mass and motion of the machine parts. So which arise the combined effect of mass and motion of the machine parts we are studying, that is called as kinetics. So statics nothing but with the branch of theory of machines which deals with the forces and their effects while the machine parts are at rest. So mainly are at rest. The machine parts are at rest. So then the mass of the parts is assumed to be negligible. The mass is not considered. So then it is called as statics. So now we are going to discuss about kinetics of machinery. So then now what is the rigid body and resistant body? So this is anyhow we are studied in engineering mechanics. So once again I am revising. So this one. So what is meant by rigid body? What is meant by resistant body? So a body is said to be rigid if under the action of any forces it does not suffer any distortion or distance between any 2 points remains constant Examples for this: soft and rod. Okay, soft, rod. So these are some of the examples for the rigid body. So that means any forces you're applying on the body that will not deform, or the position of the particles of the body will not be changed, or displacement will not be there, or deformation will not take place by application of number of forces. So then it is called as a rigid body. Example for this is rod or soft are the some of the examples for rigid bodies. Now coming to the resistant body. So a body is said to be a resistant body if it is capable of transmitting the required forces with negligible deformation. So rigid body without any deformation, it is transmitting the forces. But in this case, so negligible deformation, okay, that may be taking place. Okay, deformation takes place, but that might be negligible. So negligible quantity, then it is called as a resistant body. Okay. Example: belt, spring, fluids or resistant bodies. Okay, examples for this: we are taking belt, spring. So slight deformation takes place during the transmission of forces. Okay, that is called as resistant body. Next one is this actual topic in our syllabus first unit. So now kinematic link or element. So what is meant by kinematic link or element? So it is a mechanism is made of number of resistant bodies. Already I told you. Okay, mechanism is a combination of resistant bodies. So now that one resistant body, okay, or group of resistant bodies with rigid connection preventing their relative motion. So resistant body generally we are taking, or combination of resistant bodies which are not having relative motion between those, that is called as a link, okay, which moves relative to the other body. That is mainly, okay, a rigid body or resistant body. Generally we are taking, so most of the cases need not be a rigid body, resistant body is enough, but that is called as kinematic link or element. Simply you can call as link also. Okay, link or element, nothing but any resistant body or combination of resistant body which is not having relative motion between those combination bodies, okay, or group of resistant bodies which are not having relative motion, okay, that is called as a this element or this body, resistant body having relative to the motion, relative motion with the other body is known as a kinematic link or element. Okay, suppose this is taken two elements. Okay, one is moving like this, one is moving like this. Relative motion is having with respect to this body. So then these two are called as two elements or links. So like this you can explain for this. Okay, kinematic link. Now a link may consist of several parts which are rigidly fastened together. Okay, now suppose we are joining like this. So this is maybe treated as one link because the relative motion is not existing between these components. Then it will be treated as one link. Okay. Now example for this is links are simple example we are already studied in thermal engineering. So piston rod and cross head. Totally combination. It is joining of three parts, but it will not having relative motion between these three: piston rod and cross head. So totally one component or one element or one link. So similarly, connecting rod with big end and small end bearings. Okay, there is no relative motion between the big end and small end bearing and connecting rod. That's why connecting rod with big end, small end bearing can be considered as a one link. Similarly, and crankshaft and flywheel, okay, a third link, because crankshaft and flywheel there is no relative motion. Okay, crankshaft whatever the speed is there, flywheel is also having same speed. So that's why crankshaft and flywheel will be considered as a one link, and cylinder and engine frame and main bearings of are considered as a one link. So like this, so these are fixed link because cylinder, engine, there is no motion. So that's why this can be considered as a fixed link. So now like this, different links, okay, are available. So types of links, before going to the types of links, so we are discussing clearly what is kinematic link or element. Now coming to the reciprocating steam engine, I will explain this figure. Okay, now, so in this already I mentioned various parts of the engine. So now our reciprocating mechanism. So engine mechanism, steam engine mechanism. So piston rod and crosshead is the one single element, or you can call as link. Piston rod, crosshead is considered as a one element or link. Similarly, small end bearing, big end bearing and connecting rod considered as a second link. And third link you are considered as crank, crankshaft and flywheel. So these three are they considered as one link because there is no relative motion between these three parts. So that's why these three are considered as one link. Similarly, cylinder, engine frame considered as one link because this is having in between this cylinder and engine frame there is no relative motion. So this can be considered as a fixed link. So now, so total 4 elements or 4 links will be there in the reciprocating mechanism. Okay, that's why it is called as 4-bar mechanism or simple mechanism. It can be called as only 4 elements are having, then it is called as simple mechanism. If it then more than 4 links, then it is can call as compound mechanism. So that is will be discussed later. Now this is about the reciprocating steam engine working principle. Okay, or elements. What are the elements in the reciprocating steam engine we have discussed. Now a link or element need not be a rigid body, but it must be a resistant body. Already I told you. So link or element or kinematic link need not be a rigid body. It should be a resistant body. At the same time, it should having relative motion to the with other body. That is another thing. Okay, a body is said to be a resistant body if it is capable of transmitting the required forces with negligible deformation. So already discussed this one. Okay, body is said to be resistant if it is capable of transmitting the required forces with negligible deformation. So all elements or links must be a resistant body, need not be a rigid body. It may be a rigid body, but need not be rigid body. That is the one thing. Okay. Thus a link should have the following 2 characteristics. So what are the characteristics required for this link or element? It should have relative motion. Okay. With one element, other element. So this should be having relative motion. Relative motion should be there. So it must be a resistant body. Another one. Second characteristics required is it must be a resistant body, need not be a rigid body. Okay. So generally you can say that what is meant by element or link, it should be a resistant body. That body having relative motion with the other body, then only you can call as link or element. Now we can observe only binary link. I call as one is called as binary link. First figure you are observing. Binary link means only one element which is having joined by 2 points. Okay, it is a link, but only one body, one resistant body. But coming to the second figure, we are observing 3 resistant bodies are joined, but there is no relative motion. These 3 bodies are joined as one element or link. 3 bodies are joined as one element or link. That is called as ternary link. Ternary link because 3 joints are having. Previous figure where 2 joints are observing one element. So that this is called as ternary link. Similarly, third figure you are observing quaternary link. So that is 4 joints are having. So that is called as quaternary link. So this totally one element only, but joints are joining different 4 resistant bodies are joined as one element. That is called as quaternary link. Okay, this is about the link. Next, coming to the types of links. So what are the different types of links? So first part in this first unit we have discussed definition of element or link. So element or link nothing but it is a resistant body which is having relative motion with the other body. That is or other resistant body which is having, then it is called as a element kinematic link or element, or simply you can call as a link. Now types of links. So different types of links are there. So first one is called as rigid link. Okay, types of links. So mainly divide into three types. One rigid link, flexible link, and fluid link. First we are going to discuss now rigid link. So a rigid link is one which does not undergo any deformation while transmitting the motion. While transmitting the motion, so if any deformation is not taking place, then it is called as rigid link. So example already I discussed, it is a shaft or rod. Okay, that is called as rigid link. Strictly speaking, rigid links are not available or not existing. Okay, because even slight deformation takes place, that is negligible quantity. So that's why you can call as even crank, connecting rod. So it will not appear deformation, but slight deformation may take place by applying force or during the transmitting the forces. So that deformation is negligible quantity. So but even though that can be considered as rigid link. Okay, example connecting rod, crank. Okay, these some of the examples for this piston. Okay, this will not be deformed. Okay, generally, but slight deformation takes place, but that can be considered as a rigid link. The next, coming to the second one, flexible link. Flexible link is one which is partly deformed in a manner not to affect the transmission of motion. So it will be deforming, but it not be affect the transmission of motion. So for example, belt, rope, chain and wires are flexible links. So you are observing, so whenever the power is transmitting by the belt, so slight deformation takes place, but that will not be affecting the motion. So that is called as flexible link. Belt, rope, chain and wires are the some of the examples for this flexible links. Now and during the coming to the fluid link, so third one, so transmission of forces is also by means of fluids. So it contains it whenever contained in a receptacle or vessel. So fluid is consisting in a vessel. So when motion is transmitted through the fluid by pressure or compression. So by pressure or compression of the fluid, power and motion transmitted, then it is called as a fluid link. Simple example is hydraulic brakes, hydraulic jacks, hydraulic press. Okay, these are some of the examples which transmit the fluid by means of fluid. Motion is transmitted, then it is called as a fluid link. Okay, these are some of the examples. So this may be one of the important question for considering for 2 marks. So briefly explain about the types of links. So this rigid link, flexible link and fluid link. So next, coming to the structure. What is meant by structure? Okay, so it is an assembly of number of resistant bodies. So mechanism is also an assembly of number of resistant bodies, but structure is also a number of resistant body, but only difference is mechanism, there is having relative motion between the resistant bodies, but in the structure there is no relative motion between the assembly of parts or no relative motion between the elements, then it can be called as structure. Okay, it will not be transmit the motion, it will be taking only carrying the loads having straining action. Okay, that is called as no relative motion between them and meant for carrying loads. So then it is called as a structure. Example for this is frame, engine frame or body of the machine parts. Okay, so railway bridge, roof truss. Okay, so these are some of the examples for a structure. Okay, now difference between machine and structure. Already I mentioned, so machine is having number of elements, so structure is also having number of elements or links, but there is a relative motion between the elements, then it is called as a machine. There is no relative motion between the elements, then it is called as a structure. So now what is machine, what is structure, now we will discuss. The parts of a machine move relative to one another, so in the machine parts, so but in the structure there is no relative motion to one another. So that is the first difference you are observing. So next, in the machine transforms available energy into useful work. Machine will be transforms available energy into some useful work, but in the structure there is no transformation. no energy transformed into useful work. So that is the second difference. So whereas the third difference, the links of a machine may be transmit both power and motion. So it will be transmit both power and motion. So in this case, machine members of a structure transmits forces only. So only forces are transmitting in the structure part elements. So these are the main differences. This is also one of the important question. Write the differences between or compare the machine and structure. So this is the one of the important question. So next we are coming to the kinematic pair. So what is meant by pair? Two elements are joining, then it is called as a pair. So pair nothing but two elements, two links. Okay, two links are elements of a machine when in contact with each other are said to form a pair. So whenever the two elements are links, okay, two elements are links of a machine when in contact with each other, then they said to form a pair. Pair nothing but two elements joining. So if the relative motion between them is completely or successfully constrained, if the relative motion is completely or successfully constrained or in a definite direction, that is in a definite direction only they are moving, then the pair is known as kinematic pair. Okay, simply you can call as pair means any two elements are having joint, then in a machine that is called as pair. But these two elements having definite or direction motion is there, then it is called as a kinematic pair. So completely or successfully constrained motion. What is constrained motion? That will be discussed later. Okay, now we are talking. So this complete this video. So we'll continue in the next topic or next video. So this chapter. Okay, thank you.